Hi, my name is Stefan Kulo. I work for SUSE as the lead architect for the release process, and I would like to present today how we evaluate the open source licenses in our products and the tool that we use for that, named Cabal, and specifically how I used machine learning to improve the process and to accelerate it. So the agenda of the talk is, first of all, I would like to give you some background on what open source licenses there are and what the problems with them are for us, how we structure the solution, and how using machine learning simplified the process of using this tool, and last but not least, my conclusion on what I learned on this problem for machine learning. So let's start with open source. Open source is a term that is used very often, but the definition of it is 4 clauses, I think. The free distribution, as in no costs for the sources, that the sources are available to modify, that it allows modification to create derived works, and that there are no discrimination for usage of this program or the library, no discrimination against people, use cases, platforms, etc. So why are we doing legal reviews? The main reason is that we are in need to be compliant with the licenses of the software we ship to the customers. And the fact is that open source software comes in many different flavors, and we need to make sure that we have a license to distribute it. So to guide you into the concept of the different flavors of the open source licenses, I would like to use this chart from Creative Commons that goes from top to bottom, and at the top you have software that has no restrictions on its usage, very often referred to as public domain, but in legal terms this is CC0, Creative Commons level 0. There are no restrictions, and as such all the rights are with the users. So as we go down in the chart, the first right or the first rule to be used when using the software is the by clause. That means that you have to give credit to the origin, to the author, and further down is the share alike clause. That means you have to give the sources away as you got it. You can't remove rights or add restrictions. And then we are leaving kind of the open source field in Creative Commons, and there are additional clauses for non-commercial usage and for not allowing modifications to the source, and the combination of all of that. And at the very bottom you have basically no right to distribute the software. There all the rights are reserved to the author, and this is the least open. So, but this is just an example. There are many other open source licenses and many different rule sets to apply it to the software. So, which brings us to the software that I'm presenting in LibreOffice. It is free software, and still the help menu has a document to specify the licenses that I used, and this document is 69 pages long if you scroll through it. And the reason why is that LibreOffice, Chromium, OpenGDK, Firefox, all these open source software are a huge collection of libraries, building tools, documentation, and everything comes with its own different set of licenses. And the fun part is that it's not so problematic if you're distributing sources as upstream projects do. The problem with the mixing of these libraries and the challenges that come with the different set of rules are only when you compile and distribute the software to users. So this is where we are, SUSE. So To give you a guidance on how many different licenses we see. These are the licenses found per source file. We have in blue a lot of GPL 2 or 0, 2 or later, also GPL 3 included licenses. We have Apache, we have BSD 3 clause, BSD 2 clause is also there. We have GPL 2.0, that is only GPL 2.0. For example, the Linux kernel is under this license. We have MIT, we have the Boost license, and we have also GPL 3 coming that excludes GPL 2.0 then. But the main point of this slide is that we have 1,050 other licenses that are in source files present in a SUSE distribution. So we are talking about a huge collection of licenses and their mixes. So the derived works that we have are adding libraries as a result to the binaries that we are shipping. And then this mixing of licenses is also meaning a mix of rules. So that we have to basically comply to the rules of the Apache license and the rules of the GPL or the MIT. And this is a problem that not all open source projects are aware of. So we have to make sure that we are an additional safety net, that we do not trust the open source projects. Of course we do to a certain point, but we have to make sure that we are really having the license to distribute the binaries. For example, GPL version 2 and version 3 are not compatible with each other. That's why it's important that code is under GPL 2 or later, so that you can actually redistribute it as a GPL 3 version, just to give you an example on the problems that we are facing. Another aspect is that licenses very often contain explicit exceptions, either by adding or removing rights. Famous examples are licenses that explicitly allow linking against OpenSSL, which wouldn't normally be allowed for a GPL program. But for encryption it is important to be able to link against OpenSSL. Or for example, it removes the right to use the software in nuclear plants or other usage. So how do we handle this? We have in our development process a reviewing bot called LegalAuto that reviews the sources and the so-called spec file, the build description, and if the combination of licenses in this package didn't change, it is approved and can continue to the next stage, or lawyers have to review the combination and acknowledge this combination in an external application that I'm about to demonstrate here. This is called Cavel. It is at one point for reviewing licenses, but also used as gate in our development process. So the application itself is open sourced and you can find it on GitHub in the OpenSUSE organization. When there is a new package submission, it will unpack the sources to make it readable by unpacking all the archives, to render doc documents, to extract the text from PDF and similar things. And then afterwards it does multi-pattern matching of license patterns. I will come to this in a minute. And it is rather efficient and scalable to index large sources like LibreOffice or Chromium, as I mentioned. And in the end of this process, the lawyers are presented with a summary. There will be screenshots in a minute to guide the lawyers into the package source. So these licenses have a risk level associated with it, and each of these licenses comes with a number of patterns. These patterns are checked in parallel, and the longest match wins. So we have license under the GPL, means GPL unspecified, we don't know which version, or we have license under the GPL or later, then it is GPL or later, or we have license under the GPL version 2, then the or later is excluded. So all these three strings are license patterns, and we use them to check the license of the files. So this is then the summary the lawyer is presented with. He has the licenses we found, the files that are examples of these licenses found. We also have a small pie chart to demonstrate which license dominates, and then he can review or decline it within a comment on what is the problem there. This is the normal workflow, I mean the acceptance, sorry. But there are very often problems that we need to create additional patterns. The reason why is the license texts that specify the open source license of the source file is supposed to be formalized. The GPL, for example, has a specific instruction what text to add to your sources to mark them GPL, or MIT have a similar text that is supposed to be in front of a text file. But unfortunately, this is not what's happening. Many projects add their twist to these texts to make them specific to the project. And as such, we have to do a little bit more work to do to actually find the licenses. So we have included in the patterns some variables that make sure that we are not have to have a license per file or per project, but that we can use some globbing. But still, there are a lot of ways to express the same terms. I will give you examples. So this is the BSD3 clause of a random project, and it is very close to what you will find as the normal description in Wikipedia, for example. If you look up BSD3 clause, it's legal text, that's not important here. What's important is that in another project there is some small variant of that. And if you missed it, in the third clause it now says the names of their contributors, while in the first version it was the names of its contributors. So it's a small change in grammar, but it's for a pattern matching system it is quite tricky. And this is just an example. There are many different ways to express the same thing. So how do we find new patterns? The trick there we use is we have license snippets that are small text snippets, just words sometimes collection of words that are likely to be found in licenses. For example, the word warranty or the word redistribution. And once we found that, we try to find if the text snippet or the text area that we found these words in are actual licensed texts or not. We extract these text areas and compare them with similar patterns, and if the pattern match, or if the match to the nearest pattern is close enough, we are presenting this to the user and give him a risk estimation. And this is not so much machine learning, this is a very old algorithm called using it's not so important, but it's a very classic text matching algorithm. And how it works is, as I mentioned, the red words in the screen are the ones that are known as marking license texts: redistribution, must retain, disclaimer, copyright owner, liability. And we use these to define the area of text that is interesting to us. Everything else is ignored, and then we go back to the pattern database and check if there's something very similar. And if there is, we say, okay, this is very likely BSD3 clause, and we don't have an additional risk. On the other side, if this is very similar to a closed source license or to an Euler, then we say, okay, here's a risk, please lawyer check this. So the problem is there are, as I mentioned, too many ways to express the same thing, and as such we need to review very often if this is a new pattern or if this is just noise. So we have, with the list of keywords that we found to identify new licenses, we have a lot of false positives of comments, for example, that talk about API documentation and say it's the caller's responsibility to redistribute the tree, which is it's using the same words as licenses, but it's clearly not a license. And there are many other examples like this. So this is a continuous effort to filter licenses and non-licenses that would create new patterns. So this work, unfortunately, is to be done by human beings, and most of the time this is done by a lawyer that is familiar with open source licenses. So it's very resource intensive or wasted time of a lawyer. So the thought of using machine learning there is quite natural nowadays, but it took quite some time to get it right. So what we have here is a typical classification problem. So we have to define, is this a license or is this not a license? Is this worth creating a new pattern or is this not worth creating a new pattern? And these classification problems have been around for a long time in computer science, and classic examples are spam or non-spam. You might know that from your mail client, but you might also know that it's not so reliable. Other examples are defining news categories of an article, or defining if a review on a web page, on a user review is a good one or a bad one. Similar cases are to be found in research papers. Wikipedia is full with algorithms to solve this problem, but none of them is really obvious. There are many small variants of known algorithms, and each of them would require tons of time to find out if it applies to this problem or not. And yeah, we actually don't have the time to do so, and every attempt that we had failed, unfortunately. So this is the fourth effort I made to reduce the impact of the pattern creation, and I think it's good enough now, but let's get into the details. So for classification, it's important to know what your classes are. I already mentioned, is this a pattern or is it not a pattern? So the first trial I had was defining around these license snippets, or the keywords, a 3-line area, and then asked a user first, is this a license context or is this not a license context? So in this screen you find first clearly a license context that uses the word confidential, and I won't read this now. And the second example is just talking about confidential data on some storage, and this is just technical context, so clearly not license. So in theory this should have worked fine. The problem is, in reality there are tons of cases where it's just too hard to answer for a human to say if this is legal context or not, by defining these 3 lines. And the problem is, if spam and non-spam become spam, non-spam, spam I want, non-spam I want to ignore, or similar cases, it's getting complicated to actually write a good qualifier. The classes need to be sharper, and I failed in this attempt. So it requires more context than this single word. So the next introduction I had was I looked into continuous text areas. So if the confidential hit is close to another keyword, I merge these areas up to a specific heuristic. And so we are looking no longer for a fixed size context, but to a floating text area within source files. And the snippets then, the merged snippets can be full file size if the context continues to grow. And if you're looking at a copying file of a GPL or MIT, it's actually the goal of the system to have the full license in the pattern match. So this is one example. This is a snippet from some LGPL source file, and the green areas are those that we already have a pattern for, a license pattern. So this is already GPL3, and the red areas are areas where we only found licensed snippets. So we think the red areas are likely licenses, but we don't know for sure, and we know that around these areas are also areas where we have known license texts. So then the combination is presented to the user, and the user then has to decide if this is a new pattern or not. So in this case, it's clearly a yes. And then also we add some heuristics on the closest pattern match. So the closest match of the snippet is in the orange area below, and it says it's 86% similar, and the old one is LGPL3 or later. So the user can then easily create a new pattern from this information. So the question though is it worth to create a pattern or not? This is easier than it sounds. For example, if one perfect license text contains a typo because someone used search and replace over the source file and also hit the license by this, happens more often than you think. Is this worth creating a new license pattern, or is this just noise? For example, or if for the help dialog in an application the license is used in source, is this then a license text or is this code? It's in gray area. Or, for example, in an FAQ discussing the license, is this a legal text, or is this just a document that has no legal obligation? And changelogs that mention that the license was changed in the past, is this a yes or a no? These are the gray areas, and there are certainly more. But can we teach a machine our preferences if we want to create a pattern for this area or not? And this is where it got interesting, and I did quite some research on research papers there are about classification, and I used I made quite some experiments, but the one I ended up picking was character level convolution networks for test qualification from Chinese researchers. And the good part about character level classification is that I don't need to invest into pre-processing. I don't have to make up my mind beforehand what are actually significant words or what are the specifics about the text that I have to care about. The characters that are specific, that are significant for this problem, are actually calculated by the neural network. So the problem is that these research papers for these qualification problems, they have corpuses of 120,000 or more samples. And when I started, I only had very little good or bad cases. Meanwhile, I have a good base, but when I started, it was really a problem. So the model, for those who want to know, as described in the paper, is it has a convolution layer, it has some pooling layers, and at the end is full collected layers to actually output the qualification. You can look up the name of the research paper if you want to know more details. I don't want to dig into this in the time I have. And I found a very nice implementation using Pytorch. It's a licensed MIT, you can find it on GitHub. And the actual model code is less than 50 lines of Python. The most code that there is in this model is about data processing, to read the files, to actually create the alphabet and stuff. The text areas are cut at 1024 characters, so we're only looking at a kilobyte of text, even if there's more to it. The alphabet is reduced to 70 characters. It's important for the matrix. So I put them here, but it's kind of the obvious choice. But what is important to see here is that it's the Latin alphabet and some special characters. There's nothing about foreign languages. Everything else is mapped to a space. I used some Amazon instance with a GPU for roughly a week to experiment with different hyperparameters, and in the end I needed way less nodes in the first layer and in the pool layer than recommended by the paper, and a quarter of what was recommended already led to an accuracy of 99.7%, which was very astonishing, and I never looked back into looking into further research papers because this is really like gold to me. Once I had the model calculated, I use now the snippets as I found them in the text files, in the license text, and qualified them on the classifier. It no longer runs on GPU, it just in a container on CPU, and the snippets that are not considered worth a pattern are actually ignored for the review. They are presented as to be ignored in the application, and the remaining 20% of good positives are presented and, as I mentioned earlier, compared against previous patterns. So over time it becomes very easy to specify the license of the new patterns because we have comparable patterns in texts, so that the actual work that the lawyers have to put into the risk analysis is actually worth it now. They are no longer doing text qualification manually, they are doing risk analysis of existing licenses. The problem with mixing the licenses won't go away soonish. We need the expertise of the lawyers, but the actual path towards it is a lot faster now. So my conclusion for this problem is that machine learning is much more complex to get right than what most research papers or papers in general make you believe. The research papers very often contain black magic for my taste. There are very often hyperparameters falling out of the sky, or neural network connections that are not obvious how they ended up there. The problem itself needs to be very well defined. You can't start without having an idea what you actually want to achieve. The data needs to be well structured. You have to make sure that you know what you're classifying, and in the middle of the project you can't change your approach. You need to start from scratch if you failed, and then you need to classify also from scratch, for my conclusion. So, Thank you for listening. I hope I could guide you a little to my work, and if you have questions, let me know the way it is supposed to work in SUSECON Digital. I don't know actually. Bye.